Hello, welcome. Let's try to solve another Leetcode problem. So for this problem, actually we are going to calculate the weight of the last stew. The problem is that we are giving an array. Let's just use an example. Maybe we're gonna use 2, 4, and 7. Yeah, and we are going to return the minimum value. So what's left behind is that it's going to be only one stew, or there will be no stew, so we're going to return 0, or we're going to return the smallest stew. Yeah, and for this example, as we can see from it, it's going to be something like 7 minus 2 minus 4, so it's going to be 1. But it could also possibly be like 2 plus 6, 2 plus 4, it's going to be 6, and then 6 minus 7, and we're going to choose the absolute value, it's going to be 1 as well. Yeah. So this means for such kind of problem, first of all, we're going to turn this problem into a 0-1 knapsack problem. So the idea is that because according to the problem, yeah, we are playing the game with the stews. So for each of the turn, we can choose any 2 stews and smash them together. So the condition is that if x is less than and equal to y, so this is the condition. If they are equal, so it's going to be 0. So if they are not equal, so it's going to be the absolute value of x minus y. Yeah. So if the calculation is like that, basically we're going to turn this problem into a 0-1 knapsack. So the idea is that for each of the number, we're going to have plus or minus decisions. But definitely we will not do something like 0-1 knapsack. We're going to choose it or not choose it. Here, we're going to choose a plus or we're going to choose a minus for each of the value. In this way, we can solve the problem. Yeah, because this is exactly the simulation of the problem. So for this one, for example, we're going to have a minus 2, minus 4, and plus 7. So the result is going to be 1 because the absolute value is going to be 1. Or we can have something like plus 2 or plus 4 and minus 7, so the absolute value is going to be 1 as well, but we're going to choose the minimum value. Yeah, because only in this way we can do the simulation. Yeah, so for each of the number, we're going to have a plus, so it's going to be 2, and we're going to have a minus, so it's going to be a minus 2. And for the next number, continually we're going to do this, and we're going to have a 4, and we're going to have a minus 4 for each of the number, minus 4 here, and for this minus 2 as well, so we're going to have a 2, and we're going to have a 4 and minus 4. Yeah, and after that, for example, this 4, we still have 2 decisions. We're going to have a 7 and minus 7. Yeah, so the final result is going to be the minimum of the sum of all those values. Yeah, now let's just simulate the problem. If we can think about this problem like this way, basically, yeah, we've already solved the problem. So I'm going to prepare a maximum value. It's going to be the maximum of stews because this is easy for me to check. So if the sum of all those values is more than the maximum value, definitely it is not okay. Yeah. And I'm going to prepare another variable. It's going to be the length of the stews. Finally, I'm going to return a DFS. It's going to be starting from 0, and the total value is going to be 0 as well. So this is going to be my final return. So now let me prepare a DFS, but I need to use a cast. So I'm going to start from the index I, it's going to be 0, and the total weight of the stew is going to be 0 as well. So first of all, I'm going to check the total weight of the stew. So if it is more than the maximum value, definitely I'm going to return an infinity. This means it is not possible. Yeah, and now I'm going to check the index I. If it is equal to the length of the stew, so here it is n. If it is equal to n, definitely I'm going to return the absolute value of this total value, because this total value can be a positive or negative value. Yeah, for example, let's just use example like very simple example 2 and 3. It can be 2 minus 3, or it can be 3 minus 2, or it can be 2 plus 3, or 3 plus 2. It can be have different cases, but what we're going to return is the absolute value of 2 minus 3. It can be positive or negative. This is why we're going to return an absolute value. Yeah. Now we can start the 0-1 knapsack. So basically, we're going to choose the minimum of 2 decisions. Yeah, so it's going to be DFS, starting from I plus 1. And if we decide not to choose it, if we decided to make a value of plus, so it's going to be t plus those I. So another condition is that I plus 1 to t minus those I. Yeah, so these are the two conditions. Yeah, I think that's about it. Definitely we cannot set a 0 because two stalls must be calculated. Yeah, if they are going to cross with each other, definitely it's going to be a minus. But why it's going to have a plus? So this is the preparation for the next. So 2 plus 2 maybe prepare for the next. Maybe next value is 4. Maybe 2 plus 2 is 4 and minus 4 is going to be 0. This is going to be the minimum value. So this is why we're going to design such kind of algorithm with plus and minus, because we're going to calculate the minimum value. Yeah, currently I have 2 plus 2. It is okay. Maybe if the next number is going to be 4, it is better for me to use this 2 plus 2. Or maybe I only have 2 and 2. So I'm going to use 2 minus 2. So it's going to be 0. Yeah, so this is the idea. Now let me just run it to have a check and submit it. Yeah, as you can see, it works and it's pretty fast because the time complexity is I times t, and I is the length of the stew, it's going to be 30, t is the maximum value of the stew, it's going to be 100. So the final complexity is going to be 3000. I think that's about it. Thank you for watching. See you next time.